it would behoove others in other industries like medical devices or telecom or aerospace to do the same thing, since we desire simultaneous engineering anyway. Now, how does visual management relate to design and development? Well, we first must look at the wastes involved. In a typical design and development process, there's an extreme amount of a lack of visibility of a project's progression and the problems that are apparent that lead to long delays until it's too late to recover, especially in the design world where everything is so well hidden in cubicles until we finally have our big 1-month batch design review. What are the results? Waiting. Sales and marketing, customers waiting for the designs, and of course waiting is one of our key 8 process wastes. Well, our design and developers can learn from the manufacturing world of Lean that visual management can be very handy and very useful, especially since we focus on expectations versus actual results. And we look at results posted at the location of the action for everyone to see, which is especially useful to a chief engineer and top management who are doing their own leader standard work and making sure that the project is progressing as planned. Now, visual management might include management of projects, milestones, actions, resource capacities and project dedication, ongoing risk assessment throughout the project. You are limited only by your imagination. These visuals can be manual or on electronic displays, but they must be visible at all times. And that does not mean that they're just accessible in a database where everyone has access to them. That doesn't work. They have to be visible and out in the open for everyone to see whenever they wish to see. So I think it's a good idea to give you a demonstration of what a visual project board might actually look like. So if you can imagine this entire board perhaps hanging in an engineering conference room or in the engineering open space area out there for everyone to see, I'm going to give you an idea of what that might look like. So let's say that we're going to have a 2-week action plan. And we'll make that center stage of our big board, okay? And on this 2-week action plan, basically what we would have are some names of the individuals who are on the team. We'll just put letters, names of A, B, C, and D, okay? And since we are talking about 2 weeks, we would have week 1 here and week 2. And each of the different people would have different actions, again, openly out there for everyone to see. So it's clear, there is no lack of communication. Everyone knows what the expectations are. Remember, so much of the Lean mindset is about actual expectations versus actual performance. Here's our expectations of what certain people should be doing. Now, we might also have some planned work. And this might be something that's out there for everyone to see, so it's real clear. Oftentimes, teams and individuals get pulled in different directions, and we don't have a control system on our unplanned work. We need to control that somehow so that people don't get pulled off and pulled away from what they're supposed to be doing with regard to the project. Now, additionally, you may have other things on your project management board. Perhaps you have something like a project timeline. And we'll call that project timeline. And of course, this is time. And with regard to expectations, this is what we're looking for regarding completion. But we also are going to monitor this, perhaps on a weekly basis, or whatever the team decides is correct, and monitor how we're actually doing against the project timeline. Again, expectations versus reality. Another board or chart that you might have is to manage risk, a very hot topic right now. Risk management. How do you do that? What are certain ways? Well, of course we know that risk should be decreasing with time. So when we start a project, risk might be at a very high point, but then as we go on and we start to design and we start to resolve some of our issues, we would think that risk will decrease over time. That's our expectations. Now there are ways, very creative ways of measuring and monitoring risk and comparing it to actual results so that we can ensure that we do decrease our risk as we go on and we make smart decisions about the progress. Now, visual management has a strong relationship with daily accountability meetings. And the reason for that is because our daily accountability meetings are conducted at the visual project boards. This is where the meeting's held. But before we just go ahead and do this, we need to be asking ourselves, well, what's the reason and what waste are we trying to eliminate? Well, the waste is in the form of our batch mentality of conducting normal or typical meetings, like the monthly engineering review meeting. That's monthly. This is daily. The difference is when you have a monthly meeting, there's an accumulation of issues and projects to discuss, many different issues and projects to discuss, and so therefore oftentimes those issues and problems are not discussed very well or very much in depth because there's just not enough time. So that waste is excessive inventory of these issues, and that's one of the 8 wastes. Now, the daily accountability meetings, they provide the updates and the progress to the cross-functional team on a very frequent basis. Now, in the engineering world, daily is not taken quite so literally. It could be. Many projects people still do meet on a daily basis. But in the engineering world, it might mean 3 days a week or even weekly, depending on the criticality of that project. Okay. These meetings, like the ones on the factory floor, are meant to be frequent, short, stand-up meetings by the visual project boards. They should be quick reviews on action status. That's what we see here, action status and planned work and unplanned work. And they should also be addressing the problems that have occurred as a result of perhaps some of these actions that are taken. And there should be comparisons of actual versus expected results, like for the project timeline and perhaps risk management in this example. This process also eliminates the traditional reliance on the typical phase gate approach to development that so many companies employ. You may recall in the last training session, I showed you this diagram of the phase gate approach. Now, in this typical scenario, oftentimes there might be unexpected surprises that show up at the gate, as weeks or months have been wasted, resulting in a new course that needs to be established. By meeting much more frequently in short bursts of time and thereby communicating much more often, the element of surprise and associated wastes can easily be averted. Let's now talk about the relationship between standard work and product and process development. We first must address what is the purpose of standard work. The purpose is to reduce the inconsistencies and the waste of defects that results from having multiple approaches without that standard work. And we all know how it is in the manufacturing world. We create standard work. But then also we need to adjust the standard work depending on customer demand. So let's say that there's a work cell, and in the work cell there's 2 assemblers, and they're assembling that amount of product that's required for that day. The next day, demand picks up. It doubles. We need to put 4 people in that work cell. And so each person's standard work is about half the content that it was the day before. It has to be scalable. Now, this should also be true in the design process. Now, developing product design standards is very common with companies. However, developing process design standards is not very common and yet very much needed. I worked with a company one time that had many work cells and they had no process design standards, and yet they had many manufacturing engineers that were designing the work cells. And so of course the variability and the inconsistency was extremely high, until we started to put together process design standards. Those process design standards address such things as work cell design, 5S rules, how to do a failure mode and effects analysis properly, TWI, or training within industry job breakdown sheets, standardized Kanban systems, mistake proofing, Judoka or self-automation, and visual management standards. In an ISO 9001 based business management system, process design and standards are not even addressed except for in the automotive version of ISO TS 16949. I would strongly recommend that the automotive companies expand the scope of their process design process to include all the lean tools that we define in this video. I would also encourage all non-automotive companies to go beyond the minimum requirements of ISO 9001 and develop an LPPD process as described in this training session and specific process design standards that address all of the company's lean process requirements. For LPPD, a standardized methodology that is scalable to the project size and type, but nonetheless the same process, is essential. A heavy-handed one-size-fits-none process, which is a real tax on the development team and ends up delaying the product launch, it doesn't work. The goal of a scalable yet standard process is to allow straightforward customization of the process to the needs of the specific project types, which is based on size and complexity of the project, magnitude of the capital and resource investment, and perhaps the level and types of risk. This is where scalability of standardized work should meet up with visual management, as we discussed earlier. Risk over time should be measured and monitored, and as the project progresses and gets closer to project launch, risk should decrease. Otherwise, we might need to stop the project. So it would look like this pictorially, where we have risk on the vertical axis and time on the horizontal axis. And what we would like to see, of course, risk is high in the very beginning of the project, but we would like to see some kind of gradual progression down. And by the time you hit product launch, risk is at a low level, but manageable level. This risk and management of this risk should be visible for all to see on the project team, on visual management boards just like this one, which are reviewed then during daily accountability meetings. Now, risks could be related to the market, technical risks, scheduling risks, cost and quality risks. What happens is the team identifies these risks in each of those categories and calculates an individual risk priority number, or RPN, which is basically the probability times the impact of the project if that risk occurred. RPN then is averaged for all of the identified risks and plotted and monitored on a board like this. So we take all of our risks and we calculate an individual risk priority number, which is probability times impact. We get all the individual risks, or RPNs, from again market, technical, schedule, cost, and quality, and we average them together. So we have individual scores and we have average scores. We would then plot the average scores, perhaps on a weekly basis or whatever the team decides, and plot that risk as we progress all the way down to the end of the project, which might be week 52 or whenever. And we plot that and we monitor the actual results versus the expected results. And anytime there's a high risk, we need to do something about it. Now, at certain points in time, let's say here, we might have something called concept freeze. And at that point, we might set a bogey. So the average RPN perhaps needs to be below a certain number, and every individual RPN must also be below a certain point. Otherwise, we don't move on. Now, the same could happen at perhaps design freeze and at any other point that the team finds is important. So what we've done is we've kept this clear and consistent with the whole concept of expected results versus actual results. Now, Ron Massatelli, who wrote Mastering Lean Product Development, called this the risk burn down chart. The risk burn down chart. Because that's exactly what we're doing. We're monitoring the risk and how it burns down with respect to time, with respect to project progression. So how about one-piece flow, and how does that relate to the design process? And why would we even venture into that area? Well, the purpose is to reduce the waste of inventory of projects and thus the wait time. Sure, developing one-piece flow systems for paperwork and drawings and designs and prototypes is all applicable. Think about that when you work on a project and you don't want any interruptions. How do you do it? Don't you always get a lot done when you go to work on a Saturday and there's no meetings and there are very few people to interrupt you? That's ideally how an engineer could and should work. Sometimes I would just go away and get out of the office and turn off my email all day and work on one project, one-piece flow. In fact, I wrote 2 books like that. I would write them at Panera Bread, where I got free Wi-Fi and all the coffee you can drink for the price of 1 cup. And I would work and turn off my email and write my books. Sometimes you need that concentration. When I worked as an executive, I encouraged my staff to do exactly the same thing. Now, for some major or critical projects, it may make sense to co-locate product and process design engineers together, along with other key individuals, perhaps production people or quality, to encourage one-piece flow and immediate problem solving and resolution as they work to reduce handoffs. The room itself that they would work on has to be conducive to creativity with whiteboards and computers and whatever encourages each individual's creativity, including perhaps music. So think of the engineers, think of them working and constantly getting interrupted with special requests. No wonder designs get pushed back so often. Can you imagine an assembler or manufacturer constantly getting interrupted with special requests or part outages in which he or she would have to retrieve the parts or materials required? We don't want that to happen, and we know that. We want parts presented to them, and we want the least amount of interruption possible. Engineers must be allowed to work on one project, like an operator, one project at a time, to avoid what I call brain changeover. Their work is all mental. It's not tangible like in the manufacturing world and can't be easily reduced. They must focus on reducing the frequency of brain changeovers by reducing the interruptions. But how do you do that? So you should go ahead and put controls in place to help balance the load and not overload product and manufacturing engineers so that they can focus on their projects with as little interruption or brain changeover as possible. Now, this might include putting other projects and or tasks into a prioritized Kanban system before assigning it to any one individual. And this then becomes the scheduling system to receive engineering support rather than the free-for-all it normally is, in which anyone can interrupt engineers at any time. So your system might look something like this. It could perhaps be a 3-rack system, and of course this would be displayed near the visual management boards and addressed at the daily accountability meetings. And each one of these would have slots. Slots to put cards, Kanban cards, and slots to give an idea of priority. Priority would be at the top. So everyone's clear that the cards at the top are of the highest priority. Now each of these racks would be color-coded. This would be the red rack, this would be yellow, and this would be green. Red means the project's late, the task is late. We've got to do something about it. And the engineering manager would ensure that a resource is assigned to those actions. Yellow means we're almost late. We've got a day until its due date. And so we need to go ahead and take some kind of level of priority and assign actions as well. Yellow, of course, is higher in priority than green. The green projects or the green tasks are arranged in here by due date, and the engineers can themselves pull from the top the next project if and when they have a time opening. Now let's talk about the relationship of Kaizen events to product and process development. Kaizen again means continuous improvement. And a Kaizen event is a focused activity on a particular process or activity. The question is, does this or can this or should this apply to product and process development? Why, yes, it should, and of course it can. In fact, because of the sheer number of handoffs in a typical process, and as I mentioned before in that one case, there was over 180 handoffs. This is one way that we can decrease a great number of those handoffs by getting the team together to work together, not just review and meet, but actually accomplish tasks during a concentrated day without interruptions. You see, these handoffs, they result in the waste of forms and records and emails and time and all of its inventory and waste. And the Kaizen events can help eliminate some of that waste. These are events in which the work and the results must occur with the team working together. Now, some of you may be aware of and may have participated in value stream mapping Kaizen events, which are typically 3 to 5 days in length of time. And during that time, a cross-functional team of people work together, and they don't retrieve emails during that time. They don't go to meetings. They concentrate on improving that process. That's what we're talking about integrating and implementing into the product and process development cycle. Scheduled Kaizen events are events in which the team might dedicate an entire day in a working meeting to perhaps develop market and design requirements, or watch the prototype build and test phase to further refine all of the design and process requirements. These would be Kaizen events which would be similar to those on the production floor, in that a dedicated amount of time working together as a team is allotted for concentration on the tasks at hand without interruption, and work is accomplished as a team. These Kaizen events can shave weeks off of a traditional design effort by eliminating the inventory of emails being sent back and forth and wasting away in Outlook. There may be several events, typically lasting a day to perhaps a couple of days, away from all of the interruptions. Now, those events are going to depend on your particular project and your company. But I'll throw out some general events and record them here on the whiteboard. Perhaps you might have a marketing requirements event. And let me label this too as well. LPPD Kaizen events. Okay, so you might have one called a marketing requirements event, where the team gets together for a full day and truly determines the marketing requirements and truly determines the customer's needs and documents those to its full extent so that there is agreement and all are on the same page. You might also have a project planning and risk mitigation event. Another event that could occur would be a design 3P event, a process 3P event, and finally a production 3P event. And that will all be defined soon. Now, we have to determine who on the team, of course, is going to be involved in each of these events, because it is going to take some dedicated amount of time, and we want to make sure that all the right parties are truly involved. Okay, so we'll have responsibilities over here, and I'll, of course, have or record the team leader. The team leader, who is like the chief engineer, well, we want that person to be involved, of course, all the way throughout production. You might have supervisors. And perhaps supervisors, you determine that they should be involved in project planning, design, process, and production 3P. Perhaps you have quality, and you determine that quality should be involved all the way across the board. And another example, marketing, and we need to have marketing involved here, and as well as the design 3P. But all of this is determined, and we have many more positions of people who might be on the team, and we would determine this as a team, and they would be dedicated to those Kaizen events, which again would be working meetings in which real work is accomplished. It's not just a review. Now, each event would have an agenda and would have objectives. The advanced manufacturing tool of production preparation process, or 3P, is one part of the overall LPPD approach that includes such things as doing quality function deployment, design reviews, and post-startup of monitoring by the cross-functional team to Kaizen any kind of bugs that are still within the system. Now, the benefits of a 3P event is the rapid testing of many ideas and the embedding of lean manufacturing principles into the process and product design process. 3P, or the production preparation process, seeks to meet customer requirements by starting with a clean product development slate to rapidly create and test potential product and process designs that require the least time, the least amount of material, and the least capital resources. These are multi-day creative processes that help to identify several alternative ways to meet the customer's needs using different product designs. Also with 3P, the team spends several days with a singular focus on that 3P event, working to develop multiple alternatives for each process step and evaluating each alternative against that manufacturing criteria, whether it's designated takt time or preferred cost. The goal is typically to develop a process or product design that meets customer requirements best with the least amount of waste. And the typical steps include defining the product or process design needs, diagramming and generating alternatives, building, presenting, and selecting prototypes, holding the design reviews and making a selection, and finally developing project implementation plans. From the main team, sub-teams are formed to draw and design different ways to accomplish the process in question. And each of the sketches or drawings they develop is evaluated and the best is chosen, along with any of the good features from the sketches that are not chosen for a mock-up or a prototype. Now, creating a space or an environment to allow for the creativity to flow is very important. Sometimes this might be an ideation room, or co-locating key team members of a project, or allowing the team to determine how and where they are most creative and giving them the flexibility and space to be there. Teaching tools that help entice and spur on creativity, whether it's Dr. DeBono's 6 thinking hats or lateral thinking or perhaps even trees, or other available techniques to stimulate creative thought, is also important to the group or team. Now, what about Nimawashi? Well, instead of deciding on one design concept early in the process and constantly testing and fixing and redesigning that one concept, the approach should be one of creating and developing many different alternatives up front, narrowing them down methodically based on how well they meet design inputs and customer requirements, and reaching a team consensus on the final design, and then of course implementing rapidly, as in fast innovation. At Toyota, this is called Nimawashi. We will discuss Nimawashi in much greater detail in a subsequent training session. So, Lean is applicable to any process in the business world, and it's especially applicable in the design and development world because this process is rarely studied and looked at to see the inherent waste. Design and development is a process, just like assembly or manufacturing, and as such will have plenty of waste in the process. It takes a person who can think conceptually and see how virtually every single lean tool and cultural aspect is applicable to product and process development. Those companies that can adapt the lean management mindset to product and process development will be the same companies that will innovate rapidly and will be the first to the marketplace with new products and new services.